Well, hello, everyone. Thank you all for coming. We are going to talk about today on how to build your AI stack with a variety of technologies using partners from MongoDB, partners of our AI applications program, Anyscale, Cohere, and Fireworks AI, and using MongoDB as the underlying data layer. We're going to talk about lessons learned and things that we have done with customers and taking them from prototype to production, and things that we also see as trends in the AI vertical, right? And but again, this is a conversation, so we are certainly be open to questions. We can take maybe a question here in between, but we are going to save some time towards the end as well. I'll start with introducing myself. I am an executive architect with MongoDB. I've been with the company over 9 years, and I'm also a former customer. So I like to say that I used it, I loved it, and now I am on the company side, working with customers, and I help them going through the same experience that I had when I fell in love with the technology many years ago. I'm also a co-author of a book called Building AI-Intensive Python Applications. We have a partnership with a company called Packet Publishing, and we've authored so far 4 books. And besides that, I really enjoy working with customers, and now working as part of our MAP program, our AI applications program. Next, I'd like to introduce Marwan Sareddin. He's an AI engineer, and he's a member of the technical training staff at Anyscale, where he teaches large-scale compute and large-scale AI training with customers. He founded, before he joined Anyscale, he also founded a startup that was focused on supervised deep learning. And before that even, he also co-founded a real estate analytics startup as well. And he also a master's from engineering from MIT. Up next, I have Pradeep Prabhakaran, who is a senior manager of solution architecture at Cohere, where he really partners and becomes a trusted advisor with his customers to really unlock the potential of Cohere's generative AI platform. And prior to Cohere, he was also with AWS leading cloud transformation projects. And then finally, we have Pranay Bhatia from Fireworks, where he leads the enterprise AI platform. And previously to Fireworks, he was part of Google's Gemini API. He took them from concept all the way to multiple millions of adopters. And before that, he also has an MBA from Wharton and from IIT Bombay. And so what I'd like to do now is get started with this conversation. Again, it's really about sharing our experiences and what we've seen with customers. And we've set up a few questions, but like we said, I think we actually have probably less questions than the full hour that we have. So we're really going to be open to any questions or any topics that you might be interested in. So I'd like to start with, now we've been in the kind of this era of generative AI, and we've started seeing this for the last maybe year and a half, maybe 2 years by now, right? I'd like to start off with maybe what are the key factors that we're seeing with customers as we help them build out AI applications or LLM applications, right? What are those key factors that are essential to building and launching things? So maybe Pradeep, I'd like to start with you.
Sure. Thank you, Sig. So, key factors to consider while building applications over LLMs. Now, I will start with data first. Data is the foundation. Clean data is where it all begins. Now, whether you use data in the form of anywhere as part of your retrieval augmented generation pipeline, or you're using data as a means of customizing your models via fine-tuning, or even using it for post-training or pre-training, data is the foundation. Data is really the key here, because ultimately the quality of data determines what comes out of the LLM. So that to me is key. Second is performance efficiency and cost. Now, LLM training as well as inferencing can be substantially high, right? So we want to be able to design applications that can run on smaller hardware, but at the same time ensure that it is able to perform with low latency and high throughput, right? So inferencing and the infrastructure needed is key. The third point I would stress on is privacy and security. LLMs, as Amazon would say, security is day one. So to that extent, customers are concerned about, let's say, when we use data as part of a prompt, how is this data going to be used, right? Will that data ultimately end up in the model training process, and eventually will it come as an output? So customers need to consider how do we deploy these models? Now, do you deploy it in fully isolated environments within a customer's own VPC, or even within a completely air-gapped environment within a customer's own data center? Or are you okay deploying it in a model provider's infrastructure via an API calls? There are multiple ways in which you can consume these models. Finally, the last one I would say, last but not least, the UI design itself. The UX plays a key role here, because ultimately we want to be able to build applications where it's so easy for customers to consume these models, because ultimately the more usage happens, the better feedback, and therefore better the models can get stronger. So that's where I would start.
Perfect. How about Marwan, from your side? What have you heard from Anyscale as you work and you train most of the engineers that are now building the applications?
Yeah, I'd add to what Pradeep was saying on the performance cost trade-off. I think one very safe assumption to make is that these AI workloads are going to scale. So what that means is your training is going to scale, your inference is going to scale, and for that you want to ideally leverage the most cost-efficient approach. Meaning if you have your own hardware that you've reserved capacity for over the next X years, you want to use that. You don't want to pay for some very expensive third-party service to do that. At the same time, you want to do this without sacrificing performance, right? So you want to do this at good latency figures and good quality of your models. So I think in general, if we borrow from the well-architected framework that AWS sort of preaches,
exactly,
it's about operational excellence,
right,
and sort of a balance of optimization with scalability.
Yeah, I think the well-architected framework is something that I think still applies, right? Because I think in the end, AI applications or LLM-enabled applications, in the end, they are still enterprise applications, right? All the concerns that we know about security, performance, cost, even sustainability are still applicable, right? How about Pranay from your side on Fireworks? What are you hearing?
Yeah, maybe the one thing I'll focus on is latency and speed of interaction. So for a lot of real-time use cases where either you're chatting and dynamically creating something with AI, or you're creating code and editing it, just the speed of interaction really makes a huge difference to product engagement, and it can make or break a use case. And that's, I think, one of the cases where you may have been experimenting with the most powerful models initially, but they aren't the fastest models. And as you get to the point where you really want to test your use case and scale it, you want to think about, can you move to a smaller model, fine-tune a model that is faster for your use case, and that can make a huge difference in engagement. So I think that's really something that we see quite a bit.
So I think the key takeaways are going to be going back to the basics, or not the basics, but the essentials of building large-scale enterprise applications. Again, AI apps are still enterprise applications, right? But now we need to really consider the factors that are going to scale in terms of the cost of training, the cost of inference, right? When do you need to train your own data, or rather using your own data, versus when can you use the LLMs that are already generally trained, right? Perfect. How about, as we've helped out now customers build out this and large time in production, what are the kind of lessons learned then that we have gathered as we build out AI tools and technologies, right, that can help our developers, get to these end applications?
Yeah, I think one key insight for us is that models are becoming more and more multimodal. And what that means is we have to leverage more multimodal data sets.
Yeah.
So one key partner of Anyscale is Runway ML, and they're building these amazing video generation models. But that means they need to make use of images, audio, text, and that requires setting up a very complex compute infrastructure. So this is where we're seeing some new distributed computing tools like Ray come to the scene, and offer that flexibility and scalability that you need to set up this compute infrastructure. And I expect this trend to only continue to increase going forward.
I recall, by the way, the reason also why I think Marwan might have mentioned this. He authored a very extensive and thorough guide on using MongoDB with Anyscale for understanding multimodal, right? Images, assets, and so on for an e-commerce application. And it's available both on Anyscale's and MongoDB's website, by the way. Really thorough, by the way. It's really impressive.
Thank you.
How about Pranay from your side?
Yeah. I think one of the unique things we're seeing increasingly is the power of compound AI and compound AI models. So this is the idea that you can take a bunch of specialized models, put them together, and actually get better performance and accuracy on your task than the general purpose frontier model. So we released a model recently called F1, which is a compound AI model, beats GPT-4 across most benchmarks. But then you also have like the Quen reasoning models, QWQ, that have come out, et cetera. And so I think it's really interesting to see that systems can outperform just the general model. And again, it's really worth, like, once you validated the quality of your use case, to invest in, is there a system that can perform better than just the base model out of the box?
Now, wasn't there an F1 event in Vegas last week? I mean,
Yeah.
was that Partner by Fireworks? Good timing, right? Great. How about Pradeep? What are you hearing from Cohere?
So one of the striking learnings that we had over the year and a half building applications on over LLMs is that, models that perform exceedingly well in synthetic benchmarks often struggle when it comes to real life messy business environments, right? So in other words, the largest model often may not be the best one for specific use cases for businesses. So what we have seen, therefore, is that smaller models, when they're fine-tuned for very specific use cases, can perform exceedingly well than much larger models that are trained on general data, right? So customization, therefore, is the key here. So either way you look at it, context is really what drives all of these. The second thing I would also say is, from a learning standpoint, that is power of collaboration here. There is a huge open source community here. So there's a lot of learning that we do from each other in terms of, so you talk about LangChain, LangGraph, whatever, Llama Index. So there's a lot of tools that are coming that are enabling us developers to consume these models in a much easier fashion. So there's a lot of collaboration that we all can make use that can help just make it easy for consuming these models.
So some of the key takeaways then are, first of all, data is no longer just data structured or unstructured. It is now multimodal, right? We need to really handle, obviously, PDFs, documents, all kinds of data files, XML, CSV, TXT, etc. We need to handle video, audio, right, images, and so on. And be able to leverage that together with data that companies have been amassing now for really decades, right? I mean, we all probably went through the big data, wave about 15 years ago or so, right? And companies were really amassing data back then, knowing that they may not be able to get value from it, but they knew eventually they will, right? And I think we're entering that, or we probably are in that space already, right? Especially now with multimodal models, it's going to become much easier to get value out of that data that we've been amassing, right, for a good amount of time. I think synthetic data is also another great topic, right? For example, how can you use synthetic data to train models where the synthetic data can, for example, skew, right, the way that the model might infer, right? And actually, that might be kind of a sideways topic. Have you guys heard anything around that, where synthetic data can, in a way, alter, what the models end up, inferring?
We've seen some customers have really good success with kind of using real data as the seed to then create more synthetic examples around each of the categories of use cases that we see. So I think if you just create synthetic data distinct from your real data, you run the problem of just being out of distribution. But if you use the real data to create the right categories and then synthetic data to kind of fill in the gaps and create the volume of data for training, that's something we see a lot of customers have success with. And that allows them to train to a smaller model, which again makes it more cost efficient, makes it more performant, speeds up latency. So that can be really powerful.
Absolutely.
And maybe one thing to add to that is you might synthesize across modalities. So you might have images that you could generate descriptions from and then use those for your fine tuning. So sort of enriching certain modalities of data from others.
How about using Ray to generate and try different ways of different sets of synthetic data, I would say?
Yeah, so Ray is a very flexible distributed computing framework. So you practically can do anything with it. But in general, anything that's data intensive, and especially with unstructured data, it really shines because it helps you sort of do your processing on both CPUs and GPUs, whereas like previous distributed computing frameworks were more like CPU native. And
Right.
it's safe to say that we're moving into a GPU native world that's dominated by NVIDIA right now.
If I could add
Yeah.
a point to what Pranay just said, reminded me of a use case that we've been actively working on, which is about language preservation. Some of these Native American languages have just a few 100,000 or less native speakers. But then the requirement is to see how can we preserve this language for posterity, right? So there is not a large data set to start with. So synthetic data generation helped us come up with at least a base set of data over which you can then start training your models, right? So,
Wow, that would be amazing. Imagine be able to speak to an AI that's speaking a language that is essentially have been forgotten, right, by humanity. That's incredible. Wow, we're entering that stage now. All right. How about, actually, that's a great use case, and maybe a great segue to the next question is what are the exciting use cases that you are seeing that you say like, wow, like we were never able to do this? Maybe that's one of those already, but you know, what sort of the use cases that you're hearing right now that are just eye-opening, and why?
Was that for me?
You or anybody?
A couple of things that come to my mind is, I'll start with personalized medicine. You know, we all, you know, as part of our, you know, visits to a doctor, hospital, etc. So caregivers spend a lot of time documenting procedures as part of their treatment life cycle, right? So whether they're using an EMR, EHR system, or in some cases just writing notes on using hand, but still there's a lot of time that goes into documenting these processes, right? So in my opinion, any time that is spent on creating these types of steps, in other words, any time that is spent on non-caregiving is taking that much time off from treating a patient. Right? So generative AI, I think we have helped multiple such providers reduce the cycle time of the treatment life cycle itself. That imagine the amount of time that the doctors, caregivers, etc., that were spending time while typing notes, etc., can be summarized using a generative AI model. Generally, the language model now is able to provide a summary of what actually happened over a period of time. So that actually significantly reduces not just the time, but also improves outcome and reduces the cost of healthcare in general. So that's one. The second that I'm really excited about is, and I think it's something that we all in this room might be more familiar with, which is about application modernization. Now, one of the blockers for any application modernization program is that lack of documentation on legacy applications. Right now, these might be applications that were written several years ago. It still works well and it serves the purpose. But then there is not many people within the enterprise that really knows what this application does. So generative AI is now able to explain code. In other words, code explainability, creating documentation, in some cases even creating code. I'm not saying that there is still a lot of work to be done to get that to a stage where it becomes fully automated, but still saves significant amount of time, or at the minimum is a great starter for application modernization programs.
We have an initiative also at MongoDB called exactly that, application modernization, or actually it's called Modernization Factory. Our CEO spoke of that in our last earnings call, and we're doing exactly that, where we're using LLMs to convert legacy application code, both database, obviously schema, as well as code. And one of the interesting parts of it is how do you know that when code has been transformed now by an AI, is it doing the exact same that it was doing before, but now in a completely new data model and completely new logic, right? And so what we're doing is we generate the test cases up front, right? And then you can see how far you're off. And that was mind-blowing when I learned that we're doing that, right? Because that's the one reason why people don't modernize, because how can you certify that it's doing what it was before when the experience is no longer there, right? Folks have moved on. How about yourself, Marwan? What are you hearing from this?
Yeah, perhaps like one area that also was like, it's interesting. Like I'd never thought think of semantic search, for instance, and is like the area of drug discovery, where for instance, one of our key clients is Recursion Pharmaceuticals, who basically they conduct all of these like experiments, and then the idea is you want to find like similar drugs, and so like this like semantic similarity where like you have multimodal data going back to the same, but this time it's images from like sort of microscopes or microscopes or like experiments or anything like that, and you're trying to do this search to like in this case help for like drug discovery, and there you're trying to like process massive amounts of data again. And you want to do this in the most cost-efficient manner. So I think that's a really exciting use case that we were exposed to.
For example, like X-rays of, let's say, I'm gonna say like something like lung cancer, right? You could do searches of, how is this right away by using an image versus an extensive library of previous cases, right?
Correct, yeah. And it could go down to the cellular level as well. Right. So sort of it's like a whole open space of like these new capabilities, and whether it's in search or in generation, and how they're being applied in different domains is very, very interesting.
Or quality control in manufacturing too.
True.
Yeah. True. Right. How about Pranay? Where are you hearing from your side?
Yeah, there's one use case that I love, sticking to the healthcare theme. So as a healthcare provider that works with like thousands of doctors, and they basically want to give doctors personalized advice at the point of care as they're interacting with patients on what might help the treatment. So there are lots of EHR systems that these doctors' offices use. It's extremely difficult to actually integrate directly with the EHR systems. What they're doing is basically just taking periodic screenshots of the EHR. So they have, and then like extracting information using generative AI. So you have the full patient health record. Then looking like contextually at what's on the screen right now. So they have a sense of what the doctor is interacting with the patient on, and feeding back tips and suggestions. So the idea that like you can use generative AI to empower any doctor in this way to provide better care, I think that's an amazing use case.
Nice. I'm excited about gaming. I do a lot of work in gaming. I want to be a better match with other players that are just slightly below me, because when I go and play online, I just get like thrown against the wall. So I want to be matched with just below me. Alrighty. Great. So now that we've talked about like what's coming, that's really exciting. How can we take this like really from like prototype to production, right? I know we talked about a little bit of lessons learned, but as we talk about these really groundbreaking use cases, what do you think are going to be the things that are going to really be key to taking them all the way to production?
Yeah, we have a lot of experience helping customers scale their AI workloads, and so we see like two typical challenges time after time. One is just that AI models are expensive. Particularly as you were experimenting like with frontier AI models, you're paying thousands of dollars per kind of day if you have a large scale AI workload. You need to find a way to optimize this. The nice thing about like being in the scaling phase is you also have the data to actually optimize it. So you can create good eval sets, test with smaller models, customize or fine tune models as you need to optimize your cost. And then the second thing we see all the time is like just sustaining engagement. You're going to see performance degradation as you scale your workloads unless you like consciously think about speed and latency. And so we have a bunch of techniques to help customers do that. But yeah, just cost and performance are the two biggest factors as you scale.
Which are more like day two versus day one, concerns, right?
Yeah. Day one, you're just concerned about like, does the use case even work? And the models have the quality to do what I care about. Once you solve that, then you enter this other land.
Yeah, absolutely. How about Pradeep?
Yeah, I will add to what Pranay just said, that the industry is still dealing with GPU shortages, right? So there is, even let's say your use case meets the success criteria, as you're taking your application to production, you need to think about scaling. A lot of times when you have really high volume of users and you auto scale your applications that require instances to be spun up across whatever exponential numbers that are needed, often GPU availability becomes a constraint, right? So you need to think around how to address that. And that is where, to Pranay's point, how do you build models that can be served on smaller infrastructure, but still be able to meet the constraints of latency, throughput, accuracy, and cost. So that's one. The second thing I will also add here is that LLMs, we all know, can hallucinate. Now, hallucination is really an inherent characteristic of LLMs itself. So build your applications as you're taking it from prototype to production. Build processes where you have a constant feedback loop cycle where you're able to identify something doesn't appear right, that you still have a way to validate it and then send us a feedback loop that can be corrected. So.
Yeah, I'd probably go back to the compute challenge and like basically the infrastructure challenge at a higher level. That given like most of the data is like unstructured and a lot of it's going to need GPUs and both CPUs to process. So I think like the challenge here is like to find new tooling that sort of works out of the box to do things in the most cost-efficient manner, especially like certain inferencing that you want to do at scale, like at big volumes. You want to like avoid having to like pay like sort of premium online inferencing costs for that and just process that in as cost efficiently in batches as possible. So.
I think going back to Pradeep's topic about hallucination, I think 5-10 years ago probably, you expect everything to be deterministic and accurate and correct. Like especially in the database world, you match certain values and that's the records you return and so on, right? Then we added, for example, search, right? 10 years ago probably by now, Lucene as the underlying engine. And we started getting used to more like approximation, right? It's Lucene itself or even just text-based search is not exact as a database query, right? And now we're entering the world, or we're already there, now we're with LLMs, it even hallucinates. And it's kind of a reality that we need to understand as developers and as companies that make products for our end customers, is that we sort of need to embrace it and kind of work around it, but it is going to happen, it is going to be there, right? Because being able to produce exact results at that scale would probably be computationally prohibitive, right?
Yep.
Or data prohibitive as well. Cool. Alrighty, so then as we talked about these use cases, what do you think is here to stay from what we're learning, we've learned and we are seeing, and what do you think is going to change, and maybe what's also not going to stay?
I think maybe it's safe to say that like generative AI is not like fully it's not like a revolutionary thing where it's going to like remove all of the old tooling. So like for instance, in the case of multimodal data, you might have like your classic deep learning computer vision models like object detection, face detection models. Those you're probably going to use in now, like you're going to bring in these new generative AI models and use both. So I think the classic deep learning world is not going away. So you're going to need, again, like the infrastructure that can work with both. And the other thing that I see like sort of increasing is just the modality and the size of the data sets and the models that are out there, and just their capabilities overall.
Pradeep?
To add to what Marwan just said, I think NLP and generative AI is here to stay, in my opinion. LLMs would get bigger, stronger, more powerful, but then the foundation, that is the transformer architecture, for example, that is here to stay, because they have proved incredibly useful in a variety of use cases for well over, the transformers paper came out in 2017, right? Since then, it's been 6-7 years now, so it's proved its utility. So that's going to stay is what I think. In terms of what is coming, we have already seen a lot of talk about agentic AI. Now, and in my opinion, that's only going to get more powerful. There's going to be more and more applications that are going to be served through agentic AI as an architecture. So to that extent, if I let my imagination go a little more freer, I can think of an equivalent of, let's say, autonomous driving vehicles. You could have autonomous agents, for example, that agents are able to reason and act on behalf of users independently, right? So of course, within the guardrails that you construct. So that I think is a possibility, in my opinion.
Yeah, very cool. I think the models are going to keep getting better. I think that's pretty clear that through better post-training, through inference time compute, the reasoning capabilities of models, their ability over like longer run tasks, like Pradeep was saying, is clearly getting better. I think what I've really been impressed by is how quickly open source models are catching up. OpenAI released O1 a few months back, and already in the span of like 3 months, you have like now multiple open models that have come up. doing inference time compute and having reasoning capabilities that are a step over the frontier models and coming close to O1. So to me, that's really impressive. It's just like how quickly the community and some of the big open model labs are able to match what the closed model providers are putting out.
Yeah. So the thing else that I've started hearing is instead of platform as a service, I've started hearing service as a platform. I don't know if you guys have heard about that one. No? So apparently it's just as we've been able to put software and then host it, right, to be consumed like over APIs and in many other ways. That's platform as a service. Service as a platform is about taking your vertical experience and converting that into like an LLM and a model that can, for example, imagine having a GPT model specifically for the medical industry or for the financial industry and so on, and now being exposing that as a platform as a service, but it's called service as a platform. And I think that's where the companies that have been amassing data over the last years to decades and have still the expertise, obviously, they're leaders in their space, are going to start training. That's my take. Are going to start training to the point where they can offer that experience, but now fully automated, essentially, right? Fully consumable, and that's what I'm excited about. I really think that right now we're just starting and using pre-trained models and LLMs, but now companies will start having their own, and that's going to be like their next differentiation, right? That super valuable IP that we will start to see. Great. So what about MAP? Let's talk a little bit about the MongoDB applications program. What do you feel that means to the customers, to community, and to partners, like yourselves?
Yeah, it's an exciting program, definitely. Like speaking from the Anyscale side, like we're a general purpose compute platform where you could do any of your AI, whether it's classic ML or your fancy deep learning. But we always need like a data platform to integrate with. So Mongo is like a natural choice in that case. And then in general, there's an ecosystem of partners like Cohere and Fireworks that like our users can leverage, for instance, to perform some re-ranking on Cohere, but also deploy something on Anyscale that sort of works with that and have your data backed in Mongo. So I think it's been like a positive effect overall.
It's synergy. Yeah, it helps developers get there faster. How about yourself, Pradeep?
So if you look at this diagram, the Cohere provides large language models, meaning our generative model command R and R+, and also our embedding models, embed and re-ranking models. Now they are available. You could consume these models as part of the MAP program ecosystem, but the embeddings created by Cohere's embed model that is converting text into numeric representations, you still need to have a persistence database, right? Which is where MongoDB Atlas comes into picture, whether you're storing text, multimodal, whatever, right? So this becomes an easy way for customers to consume embedded, meaning numeric representations as part of the RAG orchestration, right? So that's how we as partners with MongoDB come in place as part of a RAG orchestration.
Okay, great. And Pranay, from your side?
Yeah, so I think very similar to Pradeep's points, but for open models like Llama, Mistral, Qwen, DeepSeek, etc., if you're using those models, Fireworks plus Mongo gives you the combination of the model plus the storage and persistence. But the other thing that I'm really excited about and I think is like unique about Mongo is just like the speed of the database reads and writes. So again, if you're building real-time low latency applications that depend on having a knowledge store and models working together, then I think something like a Fireworks, which can give you really fast inference, combined with Mongo, where like the database is super fast, just gives your users a delightful product experience.
So one of the things I've been hearing a lot in the booth that we have, in the Expo Hall, we have a Gen AI showcase booth specifically for the AI topics, is the need to use different models depending on the use case, and even the need to store vectors, right, from those models in the same data set. Like in MongoDB, you could have vector 1, 2, and 3 that came from different models literally in the same JSON document, right? And that's where I think developers are starting to find that, just like we went through the API economy where you call this API for this API for that, and so on, we're doing the same now with models. And I think that flexibility, I work for MongoDB, yes, but I'm also a former developer and a former evaluator, right, of MongoDB as a database. And that's the kind of things that I still find really amusing as a developer, right? I can have a data store that's going to be as flexible. I can store vectors that came from any provider, right? As it's going to change, and eventually even maybe vectors that didn't come from a model. You know, maybe I can find ways to vectorize my own data with my own logic and still store it and make use of that, right?
Yeah, you don't want to like compromise on like basically functionalities. So like you want to have your semantic search, but you also want to have your legacy or classic search as well. And I think like Mongo gives you like that flexibility from what you said.
Yeah. Cool. So here, as just mentioned, you know, we do have the Mongo Applications Program, MongoDB. Sorry, I keep saying Mongo. I shouldn't say that. The MongoDB AI Applications Program. It is designed. It's not a software per se. It is a program that addresses many angles, right? Technology providers, hosting providers, even expertise as well. We also have partners that help the developers or customers ideate the solution and so on and implement. And what I would invite everybody to check this out. It is a very holistic program, and it is a key initiative of MongoDB, and that's why we have presence from our partners, because this is something we cannot do by ourselves, right? We are, yes, a data platform and a developer platform, but as you've heard, the expertise of different models, like from Fireworks, from Cohere, or the computing logic to be able to train at scale, like with Ray, right? Apache Ray or the Anyscale platform. All of those are going to be key as you guys think about what is going to be your next IP differentiation.